So after performing the load test on alternator, we are getting this observation table. So if you observe this observation table, your first reading is a no load reading. At the no load, we are getting the terminal voltage of 240 volt with the field current of 5.5 ampere. Armature current in a R phase is 0, Y phase is 0, and B phase is 0. So as you put on the load, so your terminal voltage is decreasing, decreasing, decreasing. Your field current remains constant, and your armature current is increases, increases, increases. In every phases, your armature currents becomes increases. Now you have to find out the voltage regulation for any one reading. Means uh, the no load voltage is a 240 volt, and the full load, as you, what is meant by your voltage regulation? It is the ratio of your no load voltage to full load voltage upon the full load voltage. By taking the 240 as a no load voltage, we have to find out for any leading. You can calculate for the 1 ampere load also, you can calculate for the 2 ampere load also, you can calculate for the 3 ampere load also, you can also calculate for the 4 ampere load. So out of this reading, you can calculate for any reading. Okay, so we first of all go for the first reading at the voltage regulation at the 1 ampere load, E0 minus V upon V into 100. As we know, E0 is a 240 no load voltage, and the V is for a 1 ampere load, it is your 220 volt. It is your 220 volt. So a 240 minus 220 divided by 220 into 100. So you are getting 9.09 percentage of. But here we are not discussing which type of the load we are connecting, as we are connecting a unity power load or lagging or leading. Here directly we are connecting a load. Okay, here we are not discussing about the nature of the load. So here directly connecting load. What's happen if directly load is connected? As we know load reading and live load reading or running load reading. So on the basis of that, here we are calculating the voltage regulation. So for at 1 ampere load, we are getting a 9.09. Then we are calculating at the 2 ampere load. So E0 again 240 minus 190 upon 190 into 100, the 26.31 voltage regulation. Then we are calculating the voltage regulation at 3 ampere load. So from the observation table, no load voltage is 240 minus full load voltage at 3 ampere is 160 divided by 160 into 100. So 50% of the voltage regulation. Then if we are calculating the 4 ampere load, okay, so percentage of voltage regulation is E0 minus V upon V into 100. So no load voltage is 240, full load voltage is 120 divided by 120 into 100. So your percentage of regulation is a 100% near about. So like this way, we can calculate the percentage of regulation at the different load as we are connecting a load across the alternator. So by performing this load test or by connecting the load across the alternator, we are performing the load test on the alternator by determining the voltage regulation of an